Welcome to Marri Reddy Institute of Technology and Management. I'm PV Murthy, Associate Professor in CSD Department. Today, I will cover a topic, Introduction to Exception Handling in Java. In this topic, we cover why these exceptions occurs, how it will be handled with a small example, and at the same time we also identify what are the different types of exceptions or classification of the exceptions. When come to the what is the meaning of exception and what is the meaning of exceptional handling. Exceptional handling is one of the most critical concept in Java programming. In particularly, an exception is an unwanted or unexpected event. What is the meaning of this exception? Exception is an unwanted or unexpected event that occurs during the execution of a program. Okay, and normally it disrupts the flow of your program. Think it is a roadblock that appears while your code is running. As roadblocks, it must stop. It can't proceed the normal execution. Okay, so whenever it occurs, it disrupts normal flow of your program. So why this exceptional handling is required? With proper exceptional handling, even a small or with a improper or without a proper exception handling, even a small error can crash your entire program. What it means? If you are not properly handling any exceptional handling in your program, even a small error can cause the crash out of your entire program. So that is the reason we need to handle the exceptions. This exceptional handling allows programmers to anticipate potential problems. That means in advance we can anticipate what type of problems that may occur in a program execution. Okay, and as you are already anticipating a potential problem during the execution of the problem, we can write code that responds gratefully these errors. Okay, it gracefully handles the type of error occurs when we written a code which can handle this potential problem. And also this exception handling routines will maintain the program stability and providing meaningful feedbacks to the users. Whenever a problem occurs, it gives a potential feedback to the programmer or meaningful feedback to the users. Okay, so what is the advantages of using this exceptional handling is it prevents programs that crashes whenever a problem occurs. Okay, it prevents program crashes. Instead of crashing the program, it runs exceptional handling routine and continues normal flow of the program. That means it keeps your application running. It keeps your application running even when errors occurs. Even when errors occurs. So whenever the errors occurs also, with the help of the exceptional handling routines, the application will run as usual. So identifies runtime errors. Whenever we are handling the exceptional handling routines, it pinpoints exactly where and why problems are happening. It pinpoints each and every possibility of the errors. It improves readability. So it makes the programs more robust and professional as it can handle all possible situations. So for example, you declared two variables a and b, initialized with a with 10, b with 0, and we are going to perform an arithmetic operation c is equal to a by b. So any number divided by 0 is undefined, Okay, in normal flow without exceptional handling, properly handling, it definitely terminates because the divided by zero error occurs. Here we can handle this with the arithmetic exception. So instead of closing down the program, termination of the program, it can rise. You cannot divide it by zero. Please enter some other number. Okay. So that message can be forwarded to the application user. This code simply throws an arithmetic exception because divided by zero is mathematically undefined until unless we define this inside the exceptional handling routines, right? So now we'll see what are the different types of exceptions. Java's exception handling can be divided exception into two fundamental categories. We are having two fundamental categories in Java exception handling. Each and every one is having its own characteristics and handling requirements. We'll see the details now. This distinction is of the most important concept in Java exception handling, as it determines when and how you must handle different types of errors. What this type of exceptions will gives us, it determines when and how you must handle different types of errors. So these two types of exception handlings or exceptions are checked exceptions and unchecked exceptions. We'll see the details now. The key difference between these two types lies when they are detected and whether the compiler forces you to handle them. So the difference between the checked exception and unchecked exception is when they are detected and whether the compiler forces you to handle them or not. Okay, so understanding this difference will help you write more robust code and avoid common pitfalls. Okay, right. First, we'll go with the checked exceptions. We'll give a small introduction to it. The checked exceptions are checked by the compiler at runtime during the compilation of the particular program or compile time. The compiler automatically checks line by line all these exceptions. That is the reason we call as checked exceptions. The compiler forces you to either handle these exceptions with the try catch blocks, or we can declare them using the throws keyword. So whenever an error occurs, that means caught at the compilation time, these exceptions can be handled using the try catch blocks, or we can throw directly using the throws keyword. Okay, if you are not included either of these two mechanisms, what happens? Simply the code will not compile. Automatically it generates an error instead of compiling. Okay, that is the main problem. So that is the reason in the checked conceptions, while anticipating the potential errors, we can handle them using the try catch blocks. So when such type of exceptions may occur is during the file operations. That means whenever you are opening a file, closing a file, reading a file, writing a file. Similarly, whenever you are establishing a database connections, whether the connection is established or not, if not established, what we need to do, that can be handled. Similarly, during the network communication, we can identify the checked, or we can use checked exceptions that can be handled by the compiler at the compile time. The other type is the unchecked exceptions. That means the compilation is successful. It is not identifying any errors, but it may fail during the execution time. The unchecked exceptions falls under this category. These exceptions occurs at runtime and are not checked by the compiler because These are not detected at the compilation time. Your code will compile successfully even if you don't handle them. Okay, but the program may crash during execution if these exceptions occur. That means it is not necessary this exception occur each and every time based on whatever the data we are providing, the environment. These exceptions may occur at runtime, but whenever the error occurs during the execution will be crashed. Okay, right. So when do we expect such runtime exceptions that is required? So it may due to the programming errors. We can also call as logical mistakes, logical errors, or invalid operations like divided by zero, or say for example instead of addition operation, if you are performing the subtraction or multiplication, it may deviate with the expected results. That may lead to runtime errors. Okay, right. So what is the problem with uh, errors in a given code? Okay, particularly during the unchecked exceptions, the programs may fail unexpectedly at runtime due to various errors like division by zero crashes your application. Division by zero crashes your entire application, or sometimes your array may access invalid locations that causes immediate termination. Invalid array access. Okay, simply that out of bound exceptions. Similarly, null pointer references bring everything to a halt. Okay, we opened a file, but unfortunately the file is not existing, then you are getting the null pointer references that bring everything to a halt. Or without proper handling, these errors results in abrupt program failures and poor user experience. So this runtime exception also must be handled. The solutions is Java provides the try catch mechanism to handle runtime errors also gracefully. Instead of crashing, your program can detect errors, respond appropriately, detect errors, respond appropriately, and continue execution without closing down. So, what it is doing, even though error occurs, it can detect errors, respond appropriately, and continue execution. Okay, so this professional approach prevents data loss. That means whatever the data we entered till now, instead of restarting, or whatever the data we entered before completion of the application, okay, it need not be lost. Okay, we continue where we stopped and maintains application stability. Okay, so the application will be stably, we can proceed its operations. The syntax is like wherever you are required. Okay, we are including a try and catch block mechanism. The try block will be identified with the keyword try, followed by pair of open plus and a closed plus, followed by a catch keyword in the brackets, whatever the type of exception we want to handle, followed by open brush and a close brush. Within this catch block, we are using the required code to handle the exception, and within the page attached with the try block, we are including all the risky code where you are anticipating a error. Okay, so what is the try block is indicating? It identifies, or we are placing risky code. where there is a chance of getting errors, okay, that might throw exceptions, will be placed as part of this try block. The catch block, what it do? It handles the exceptions. Whatever the potential errors arising in the risky code will be handled in the catch block. So the whatever the code we kept in the catch block, it handles the exception and recovers the errors gracefully. So, what is the this try block is performing? What is the purpose of this try block? Is we can identify. So, the try block acts as a safety zone where you can keep all potential risky code. That means containing code that may cause an exception. So, this try block is now acts as a safety zone. It contains all the risky code. Whatever the code we are keeping under a try block, it never allows to let down the program. It gives an opportunity to handle in the catch block mechanism, then can be continue its normal execution. So it creates a protective boundary around the potential dangerous operations. What it do? It provides a protective boundary around the dangerous operations, allowing Java to monitor execution, intercept the problems before they crash your program. Before crashing, it identifies, okay, it monitors, intercepts the problem, and sends the control to appropriate catch block where we can handle, okay, before crashing the program, okay, right. So that means it never allows, as far as possible, it never allows the program to crash down. So only thing is, be careful whenever we are using the try block, it never going to be allowed because the try block is containing the risky code. If error occurs in the risky code, we have to handle them also. So a try block must be followed by at least one catch block or finally block. What is at least one catch block? At least one possible solution. It can have the problems can have n number of possible solutions. If you are identified more than one possible solution, each possible solution will be provided using a catch block. Or else we can provide a finally block even though an error occurs before closing the program. We are going to execute the whatever the code that contains inside a finally block. Okay, so this try block never exists independently in your code. It also contains its counterpart called as catch block, right? Second point, exception flow. If an exception occurs inside a try block, what happens? The try block may contains n number of lines of the code. Error may occur anywhere from first line to last line. Wherever an exception occurs in a particular line of code, the control immediately jumps to the appropriate catch block. It may occur in the first line, error may occur in the first line, or error may occur in the second line, or error may occur in the nth line. Wherever it occurs, the control immediately jumps to the appropriate catch block. The remaining code in the try block is automatically skipped. The remaining code in the try block will be automatically skipped. So the first instance of the error occur automatically leads to its corresponding the catch block. Once it is forwarded to the catch block or whenever it is error occurred, we will monitor JVM monitoring all these exception occurrence and handling routines. So Java Virtual Machine actively monitors code execution within the try block, ready to transfer control the moment an exception is detected. The moment an error that leads to exception will be detected by the Java virtual machine, okay, and transfers control to the appropriate catch block. So here, say for example, in the small code snippet, we are having the try block int a is equal to 10 by 0. That means divided by 0 error occurring here. So immediately in that from this line itself, the code will transfer to appropriate catch block by the JVM. The line after this particular line where exception occurred is never going to execute until unless this problem is rectified. So when the exception occurs, the JVM stops executing remaining code in the try block. Okay, whatever the code it is. Okay, and looks for a matching catch block. If the matching class block is identified, control will be goes to there, or else if a finally block is there, control goes to the finally block. Otherwise, then it goes with the normal error handling routine. Right. So what this catch block is performing? So catch block is the handler to its corresponding try block. So what is the meaning of this catch block? It is the handler, the type of errors or exceptions that may rise inside a try block will be handled here. That is the reason each and every catch block we term as handler that responds when an exception is thrown in the try block, right? So it receives the exception object, the type of exception that match with the provided solutions. Okay, that exception hash will be received in the catch block, allowing you to examine what went wrong based on whatever the code we provided inside the catch block and takes appropriate corrective action. Okay, so the code in the catch block will be executed if and only if there is an exception rises in the try block. Otherwise, code execution will be successfully terminated by executing whatever the code in the try block itself. Okay, think of it as a programmer's emergency response time. If any emergency is there, the code in the catch block will be executed. Otherwise, simply it continues with the code in the try block. So first, an exception will be thrown inside a try block. Okay, then an exception object will be created. This exception object will be matched with catch blocks. Okay, we call it as a type matching. It checks if the catch block can handle this exception or not. That means whatever the exception we provided in each and every catch block header, it will be checked. Okay, whenever there is a match is happened, that matched catch block will be executed, and whatever we written inside called as handler, this particular appropriate handler will be executed if match the catch block code runs to handle the error. Okay, right. So once we executed whatever the code inside the catch block which was already matched, the program execution will be continued normally. So execution resumes after the catch block, preventing any type of errors. It continues from the line of where exception handle. That means from that line to the next line, automatically control goes from the next line onwards. The execution will be automatically handles. So the structure of this particular catch block is catch keyword, whatever the type of exception you want to handle, that exception type. So if such type exception occurs, this catch block will be identified and matched and executed, followed by a variable name. Inside between these two braces, whatever the code you want to execute, that code. So the exception type specifies which errors this blocks handles. Which errors this specifies. That means for each and every type of error, we are identified a catch block with appropriate exception type. So the variable holds details about what went wrong. Okay, we are giving a code. Say for example here, that the exception type is arithmetic exception. Whatever you want to provide, we are providing using the type as the E. Okay, the variable. Now, inside this catch block, we are going to execute a small statement. For example, cannot divided by 0. Once this statement is printed, automatically execution will be continue with the next statement. Okay, right. So exception handling in Java, we are using a simple try and catch mechanism. Okay, in order to handle whatever the exceptions that may occur in any particular program. It prevents program crashes, allows execution to continue normally after handling the error. So we provided a small class. It contains a one try block and one catch block. The try block containing the potential source of the errors, and catch block contains how to handle with the type of exception you want to match with a variable, that what type of error may happen. Okay, and what are the corrective statements. Once you are finishing this try catch mechanism, the control normally continue with the next statements. Okay, so what happened here? Exception occurs, divided by 0 triggers arithmetic exception in the above try block. Exception was caught, matching catch block executes and prints the error message. Once it prints the error message, after executing a matched control block, the execution continues or the program proceed with the next statement after the catch block. This is the simple try and catch mechanism or exception handling mechanism in the Java. Thank you.